Welcome to lecture 11. In previous lecture, we have studied about the how we are manufacturing solar cell, what and all different techniques are used to fabricate solar cell. So we have know about the solar cell and manufacturing process, different type of solar cell like monocrystalline, multicrystalline, that and all we have seen in the last lecture. So in this lecture, what we will see how we will connect series of cell, then how we can manufacture the module. So in this lecture, we will see the photovoltaic module design and manufacturing. Welcome to lectures 11. Myself Karthikiyam. The lecture outline are what and all we will learn. We will see. First is motivation for making module, then what is the protection for the cell and other electrical issue we will see. Then after all this thing, we will go for the construction of PV module. In PV module construction, we have to know about the few things that and all. What is the front glass of the module? What is the encapsulant used there? And how many solar cell connected together? And what is the backsheet? What is the use of backsheet for the solar cell? Then what is the junction box? That and all you will learn in this lecture. So we will start. So what happened? I previously told that we have used silicon material as a semiconductor device. So this is the basic PV supply chain, how it will manufacture from silicon to solar module. So in this case, what we will take? We will take first silica. Okay, then after that silica using, we are make some chemical reaction, make silicon dioxide or any kind of silicon material that converted silica into of its original form by adding some of its chemical, and it will be heat in the higher temperature, and it is go in the so number of process, some chemical process, that and all it will go through, and it will remove some impurities, unwanted thing. So we will get the some polysilicon or any silicon material, so that is containing the highly more number of covalently bonded silicon atom in that one. So whatever we are getting from this process, that is pure silicon, which having atomic number 14. So in this image, see what we will do first, silica we will get. Then what will happen? Coke reduction in the arc furnace. They are heating with the coke. Then what they will do? They will do the distillation with the dilution in the hydrochloric acid. Then next after this they will process with the 900 degree Celsius furnace. After that we will get a polysilicon cylindrical shape. Then what will do? They will make the process of doing ingots, that is containing more number of silicon, that is called a Zokarsky process. Then we will get the ingot, that are the different types. You have know that monocrystalline is in a round shape and multicrystalline that is in a rectangular shape. Then we will get different types of shaped ingots. Then what will happen after ingots will going to the process technology, using laser cutting machine it will slice small plates, that plates is called as a wafer. Then some wafering technique and some laser technique, doping, that and all done in a process with the manufacturing of the solar cell. They then adding some grids and bus bars, we will produce the small cell. Then what we will do? After getting the cell, we have to protect it from the anti-reflection coating and all. Then what they will do? They will getting a two terminal plus and minus. Then in a module manufacturing unit, they will connected each cells in a series connection. So what they will produce, each cell containing the zero point 0.6 volt. So they will connect all the cells, almost around 60 number of cells connected in a series, and they will produce the 60 cell with the 36.6 voltage of its rating. This is seen here. Okay. So by connecting all the cells, they should be protected. It will be protected by aluminum case, some encapsulation over the top of the surface, then background material to support the silicon cell. Then there will be a junction box which take the two terminal. So we know that all the cells are connected in a series which containing the plus and minus terminal. Finally, it going to the junction box where it connected single positive, single negative. So this is the basic power supply. So next what will happen, this module are installed in a different power plants. By combining so many modules series together, they will generate the power. By adding inverter, they will get a total megawatt gigawatt power of energy we can get. So this is the basic supply chain. Next, why to make modules? We know that we can't get enough voltage from the single cell. Single cell is produced only 0.6 volt. Okay, so I can't use this cell in a environment because there may be a chances of breaking. Okay, so what they will do, they set some industry standard. They make these cells in a series connection. So by connecting series of this cell, they made a one module. See, in one module it containing either 60 number of cells or 72 number of cells. So why we want to make modules? One, we have to protect from the corrosion. Okay, then breakage of this cell, we have to overcome that one. So it should not be breakable. So there may be some difficulty by connecting this cell, that we have to reduce. Like if I use only cell, there will be very difficult task to connect one cell into the our electrical system. And this cell also does not containing any electrical insulation, and it containing very low voltage but very high current. So in order to overcome all this, we have to make modules. So by making modules, we what we can do, we can do environmental protection to the cell. Then with the aluminum case to the module, we get the stability and the strength, and there will be easy of connection. There will be a standard connection, we will get the all the module. Then also we can introduce the insulation to the module system. Then now we can get a high voltage with a low current. If I get more number of module, I will get the high voltage, because when series connection of the any cell, the current will be same, voltage will be add up. Okay, one 60 cell module containing 36.6 voltage and 8.2 ampere, because one cell only generate 8.2 ampere. So by connecting series, I will get only 8.2 ampere, because in series voltage will add up, current will be the same. So how do we protect the cell? See, first of all, we have to know that how we protect the photos, that is by laminating the photos. So similarly, we have to do lamination and framing for our solar cell in order to prevent from corrosion and breaking, right? Okay, we have to do environmental protection. How I can reduce breaking? By adding, here you can see there will be a side frame. In a solar module, that frame is called aluminum frame. So that will give the mechanical strength. Now we have to see how we can connect to the electrical system. As we know that solar cell containing the two aluminum strips or silver strip, there will be a very delicate. So if I connected that to in electrical system, there is a chances of breaking. So what people are did in the industry, what they did, they all connected that negative terminal in a single bus and positive terminal in a single bus. Finally, they are coming up and joined together in a single location. This joint location is called as a junction box, each containing plus and minus terminal. So in order to prevent some shading and all, there will be some bypass diode. I will tell later why we have to use bypass diode in the junction box. How we can easily connect the solar module. This connection, you can see this is the MC4 or MC3 connector. So it is very easy to connect our electrical system. In electrical system, we are also getting the MC4, MC3 connection. So we can directly connect this module to our electrical systems. Now we will see what and all the PV module containing. So this is the series connection of the solar cell. Okay. Then after that, there will be a encapsulant that is protected over this solar cell. Then after this encapsulant, there will be a top of this encapsulant, there will be a glass frame in order to protect it from the one thing is rain, any kind of dust. For that we need glass. Then to give an strength for this entire solar cell, we need a frame that is made up of aluminum. Then below this solar cell, there will be another encapsulant that will be protected from the back side. Then after the this encapsulant, there will be one back sheet. This is also preventing this solar cell from the back side. So that is called white small thin back sheet. Then after that, we are using junction box. What is this junction box? This is nothing but all the positive terminal and all the negative terminal are joined together and took in a single place where I will get the actual voltage from this terminal. This junction box containing some bypass diode. I already told that. So I will explain later. So this is the main basic material required for the manufacturing of solar PV module. Next, what and all bill of material. So one who are going to manufacture PV modules, they know the what and all bill of material is required. So first thing, front glass and encapsulant. There are so many types of encapsulant are available that they have to use. Then major thing is the solar cell. Then PV ribbon, that is also used for protecting and get conducting path, and it should be attached together. So PV ribbons are used. Then bus bars, I already told. Then backsheet, frame, and frame sealant. It is nothing but once frame has been put together, it should not be removable. So it should be sealed together. So any single dust or any raindrop should not go inside this solar cell. Okay, we have to prevent all this. So it required frame sealant. Then junction box. Finally, that two terminals are coming outside, that will be going in the junction box in order to get the output. Then label. So while manufacturing in a plant, we are manufacturing so many modules per day. So in order to identify which module has been manufactured, we have to do naming. So for that naming, their RFID tag has been used. It containing the serial number, date of manufacture, everything data you will get. Okay, then sticker. That sticker using the data sheet, nothing but what is the voltage of that panel, what is the current rating, what is the power rating, all has been put in the back side. So that is a sticker that containing the manufacturer name, all the details. So front glass, why it is required front glass? So first thing, it is give the strength to solar cell. Also it prevent from the dust. So what is the thickness of this glass? You can see that is 3.2 mm to 2 mm, that much thickness. Because if we made thicker glass, so it is difficult to come sun rays to inside. Okay, then transmittance. So why transmittance required? This is the how much quantity of rays can be comes into it. See, transmittance is should be a 90%. It should be more than 90% rays coming inside. That the range from 300 nanometer to 1200 nanometer wavelength can be go inside. Then coating. Already we know that anti-reflection coating also required to reduce optical losses. Then anti-soiling, that is texturing. So sometime in desert situation, if we put the plants in the desert, there may be a lot of dust will be accumulated. So in order to preventing from the dust, we require anti-soiling coating. Next, composition. what and all used to make this front glass and coating. There will be a celerium and UV and boron. All this composition was used. Now we will see what type of encapsulant, why it is required. Encapsulant is placed over the solar cell. Okay, so this is also should be a transmittance because it should allow 92% of the solar radiation. So UV cutoff, it is the range around 360 nanometer. Only this much wavelength should be coming to solar cell, because let's suppose if I get higher wavelength solar radiation, that should not be coming to solar cell. So if I get high wavelength solar radiation, it may damage my solar cell. So we have to prevent some UV lights. So we need some UV cutoff in that encapsulant. Curing time, there may be like 5 to 7 minutes. Once it's putted, how much time is required? That is 5 to 7 minutes. Curing time is required. Shrinkage, whether it is shrinkable, yes, less than 1%. It's okay. Adhesion strength, what is the adhesive nature? How much adhesive to solar cell it is? It is more than 70 Newton per centimeter. And electrical resistivity, how much resistivity is containing? That is 10 to the power of 12 ohm meter. These and all the basics things present in the encapsulant. Next, we will see the solar cell. We already discussed so many times how solar cells are fabricated, but still, because we are manufacturing the module, we have to know about the solar cell basics. So, what is the technology? Either it will be a monocrystalline, multicrystalline, amorphous, or PERC solar cell. These are the technology we are call it as. Then efficiency. How much efficiency should be there? It should be 17 to 22%. Then bus bars. 4 to 5. Generally, few cells are used, maximum 4, or some cases high power module having 5 bus bars. Thickness, that is we know it is around 180 micrometer. Then coating, anti-reflection coating is must. And PID, what is PID? It is potential induced degradation. So it should be a potential induced degradation free. What is the potential induced degradation? Let's see, if some shadow is coming on this solar cell, at that moment it cannot generate the power. That is called as a potential induced degradation. Here degradation has happened due to any cloudy, not because of cloudy, any shadow. If we placed under the tree, we will get the potential induced degradation. There may be degradation in the power or voltage. Then we will see the backsheet, what and all it contains. So backsheet used in a three different layer. One is an inner layer, or in the middle layer, or in the outer layer. What is the technology? That is made of a Tedlar, polyvinyl chloride kind of thing, PVDF and PET. These and all technology they have used. How much thickness? It is also 300 micrometer. What is the WTR? This is for wavelength and transmission ratio. That is 1 to 3 gram per meter square per day. Okay. Accumulation we can call it as a. Then how much dielectric strength? What is the dielectric strength of this backsheet? How much voltage it can be sustainable? That is more than 20 kilowatt it can be sustainable. That much strength it having. So interlayer adhesion, how much adhesive it is? It is more than 5 Newton per centimeter. It is just brief. You no need to know all these things. It's okay if you don't know this one, but you have to get like what and all it containing. These numbers are not required, but while manufacturing the model, this and all numbers you have to know. So finally, we'll get to know about the junction box. So mainly, what junction box containing? It containing the low forward voltage and low resistive current. Okay, so it is maybe cooling the system, because if you are getting the high current or high power, there should be a cooling protective. So you can see in this junction box it containing the two terminal 1 2, and it is protected by the diode. This is called as a diode in the junction box or anti-parallel diode. I will tell you this anti-parallel diode why it is required. Then also this junction box should be a water protected. Why? Because if water comes inside this junction box, that will damage the system and there will be a short circuit in the these bus bars. So it should be IP65 or IP66 or IP67 protected. And how this diode and bus bar are connected? They are connected and soldered together. So lead, why it is required? Because it should be, if something or sometime if diode goes wrong, then we have to open it. So for that purpose we have to put lid. Then finally we have to get the power at the outside. We required some connectors. So that connector is called as a MC3 and MC4 connectors. You can see in plus image it is all denoted as a male MC4 connector and minus is a female MC4 connector. So in this lecture we have seen the how PV module are constructed, what are the layers included in the PV module, and we are seeing the details of each layers in this lecture. In next lecture we will go to see about the how this PV module are installed, what and all losses will occur, and what and all measurement we can take, and in the field how it will perform field, that and all you can see in the next lecture. Thank you.